Welcome to Lesson 1, Find the Lowest Common Denominator Expressions. Our objective is to find the least common denominator or lowest common denominator of two rational expressions. This is going to be an important lesson because this week we will be adding and subtracting rational expressions. And in order to do that, we need to have a common denominator. It's a little more difficult to find a common denominator when you have a rational expression because remember, a rational expression is a polynomial divided by a polynomial. So let's look at an example. Let's review. Remember that when we add fractions, you can only add like to like. So meaning you need to have the same denominators, as in this fraction here, 1/5 plus 2/5. When we add those, if we have common denominators, we keep the denominator the same and we just add the numerators. If we were to have different denominators, then we need to make them the same. We need to find a common denominator. And that is just to multiply the denominators. That will always become a common denominator. However, it's not always going to be the least common denominator. And that is a problem when we are working with polynomials because we need the least common denominator. Otherwise, we won't be writing it in its simplified form. Okay, so let's look at this one, for example, a basic fraction, 1/12 plus 4/12. If we're trying to find the least common denominator, one way to do that is to factor the 12. And the 12 is factored into 2 times 2 times 3. Remember that we have to factor it into all of its primes. We can't factor this into 2 times 6 because 6 can be factored into 2 times 3. So we need to find all the prime factorizations of 12 and all the prime factorizations of 15. This is different than finding the greatest common factor. This is the least common factor, or least common denominator in our case. So what we are trying to do then is we're trying to take one of every number. So we would just start with the first one, 12, and we know that we need a 2, and a 3 in our denominator. So we would pull that into it, 2, a 2, and a 3. Then we would look at the next number that we factored, and we would see what we don't already have, and we would include that. Well, we already have the 3, so we don't need to put another 3 in there, but we do not have a 5, so we would need to add a 5 down here to find our lowest common denominator. So what is the result? We have 2 times 2 times 3 times 5, which gives us a lowest common denominator of 60. So in this case now, we know that our lowest common denominator would be 60. And then we could adjust our numerators and we could add these fractions together. For this lesson, we are only finding the lowest common, so we're not going to worry about our numerators at this time. Okay, let's look at some rational expressions. When we have rational expressions, remember, we have a polynomial divided by a polynomial. In order to find the lowest or least common denominator, we need to factor the denominators just like we did with a regular fraction. We took the 12 and we factored it into 2 times 2 times 3. So for the polynomial, we need to take the x squared minus 1 and factor it. Well, hopefully you can remember that this is a difference of squares. X squared is a perfect square and 1 is always a perfect square. And remember that a difference of squares factors into the sum and difference of the square root of each. So x squared minus 1 factors into x plus 1, x minus 1. That's our difference of squares. Then in order to find x squared minus 2x plus 1, we would need to factor by grouping since that's a quadratic. If we were to factor by grouping, remember that we make an x, and we take the coefficient of the x squared term times the last term to get 1, and we put our middle term in the middle to get -2. Well, we ask ourselves what times what is +1 that can add to be -2, and that would be -1 times -1. Once we have that middle term split up, we just rewrite our quadratic, splitting up our middle term into -1x minus -1x, and we keep the rest the same. Then we can factor by grouping. So we can take our first group, factor out the GCF, which would be x, and we're left with x minus 1. And then in our second group, we can factor out a -1, and we'd be left with positive x minus 1. Now we have our final grouping. So what do we have that's common in the first group? as in the second group, and that would be x minus 1. So if we pull out the x minus 1, we're left with x, and in this group we're left with minus 1. And you can see down here that we have factored x squared minus 2x plus 1 into x squared minus 1, x squared minus 1. So now we have factored our denominators just like this first example here using fractions. So what do we do next? Now we have to find the least or the lowest common denominator. Okay, so remember what I said. Just take the first one. It doesn't matter which one. I'm going to take the first one, and I'm going to write everything that is in the first one, all the factors. So I know I have x plus 1, and I have x minus 1. So I always write all the factors because I need all of them. Then I look at the second one to see what we already have written down. Well, I have an x minus 1, so here's an x minus 1. But now I have an extra x minus 1, so I'm going to need that as well. So this is now my lowest common denominator, or least common denominator. And you can see that I have the x plus 1 here. I have the x minus 1, which is this one as well here. And then I have an extra x minus 1 that I need to put in for my lowest common denominator. Now I could add these fractions by adjusting the numerators, which will be in our next lesson. Let's do 2 more examples. And for these examples, why don't you take a moment and pause the video and see if you can find the lowest common denominator of these 2 rational expressions. Okay, if you're back, let's see how you did. So let's take each of these. Let's take the x squared minus 9. This one's nice because these are 2 perfect squares, so I can factor this in my head to x minus 3, x plus 3. Remember, perfect squares factor into a sum and difference. Then we have 2x plus 6, and all I have to do is say, what's in the 2x, what goes into 2x and also goes into 6, and that would be 2. So I can factor out a greatest common factor of 2, which leaves me with x plus 3. Now I'm ready to find my lowest common factor, or my least common factor. So my lowest common denominator, we'll call the denominator since we're actually looking for the denominator rather than factor. So let's go ahead and start with the first one. We have x minus 3 and x plus 3, and I'm going to take both those factors. Then I'm going to look at the bottom and see what extra stuff I have. Well, I don't have a 2, and here's a 2, so I need to put a 2 in here. I'm going to go ahead and put the 2 in the front. Then I have an x plus 3, but notice I already have one x plus 3, so this one's already accounted for. I don't need the extra one. So my lowest common denominator for these 2 rational expressions is 2 times x minus 3, x plus 3. Remember that these 2, x plus 3, I already have 1 in the x squared minus 9, and I have 1 in the 2x plus 6, so it's already accounted for here. All right, let's look at the bottom one. So in the bottom one, again, I have the x squared minus 9. We know how to factor that. We just did it. X plus 3, x minus 3. Now I have a quadratic. I have the x squared minus 5x plus 6. Okay, so let's go ahead and make our x so that we can factor this by grouping. In our numerator, we have 1 times 6, which is 6, or I should say on the top of the x, not necessarily the numerator. And then on the bottom of our x, we have a negative 5. So what times what is positive 6 that adds to be negative 5? And you might be tempted to say, well, 6 times negative 1 or negative 6 times 1. The problem is negative 6 times 1 is negative 6. So 6 and 1 won't work. So we have to think of something else. So what about negative 3 and negative 2? Negative 3 times negative 2 is positive 6, and they both add to be negative 5. That looks like it works, so we can take our quadratic and we can separate our middle term, and then we can group. First group, second group, we can factor out as x and get x minus 3, and then second group we can factor out a negative 2 and get x minus 3. And then for our final group, we have x minus 3, which is in both. We can pull that out and we're left with x minus 2. So we have x minus 3, x minus 2, which is the factorization of this quadratic. Okay, We are almost done. All we need to do now is find our lowest common denominator. So let's start with our first one. Remember, we always take everything in the first one, x plus 3, x minus 3, and then we see what additional things we need. Well, x minus 3, we already accounted for that 1 because we have one up here, but we don't have an x minus 2, so we need to put that on the end. And now we have our lowest common denominator. And this concludes our lesson on finding the lowest or the least common denominator for rational expressions. So remember, go ahead and factor the denominator as far as it will factor, and then start with the first rational expression denominator and take every factor, and then look at the second one and see what we're missing. What extra factors do we not already have listed as our lowest common denominator? If you get in the habit of doing a very structured process, it will be easier to remember it, especially when we start adding and subtracting.